Hi guys, my name is Sushank Singh and this is my project for market anomalies. So this is my Jupyter notebook. Hopefully you can see it. And I'll start by downloading all the dependencies. So we got pandas, numpy, OpenExcel because I downloaded the data in Excel, so I had to use this. So I had to uh, install OpenExcel as dependencies, then scikit-learn, matplotlib, TensorFlow, Keras. First start by importing all the modules. Then we start with importing our Excel file, and I changed the heading column to the fifth row, which is this. Then I imported the variable df as a data frame, and this is the first 5 data values from the Excel. Then I print out all the columns so I can make a new variable, new df, and have a data frame assigned to it, which would import the values of this, and this from the Excel file and make a new data frame. And here I renamed the file, renamed the columns. Here I drop the null values, reset the index to 0, and print. So this is how the new data looks like. We only have the date, VIX, NASDAQ, 30-year treasury yields, and gold future. Then I first start by doing a correlation matrix, which is this. Then I check to confirm if we have any null values. We don't, that's why it's 0. Then here is just some data analysis on the values I have. Here I do a statistical anomaly detection using the z-score. I change all the values to absolute value and I compare it with the threshold, which I've given it 3. This is the answer I get. Then I plot VIX Index price over time in a box plot, and you can see the price has mostly stayed between this $11 to $27 mark. Then I start with training an LSTM model. So for LSTM models you have to create sequences, which I did over here. Created the sequences, prepared the data, and on my features I'm using this. I have decided to drop the date column, which is useless. Then I scale the data, create sequences, split it into tests, and train. Here we build the LSTM models. Here I'm using 64 units and I will drop 20% of value so there's no overfitting. So we're going to, when we train the model, we'll have 50 epochs. Each batch will have 32 values of data, and after we run it, looks like this. So it's training the LSTM model now, and it has finished training. Now we'll use the trained model to make predictions. We have trained it for predictions. Now we visualize. So here I have plotted training and validation losses. So on the top plot, the blue line represents the training loss and the orange line represents the validation loss. Both lines decrease over epochs, indicating the model is learning efficiently. The gap between the two lines over here, The gap between two lines is small, suggesting minimal overfitting. And the bottom plot, the blue line shows the training MAE and the orange line shows the testing MAE. The red dotted line is the anomaly threshold, which is this. Spikes above threshold indicate anomalies in data. So anything over is an anomaly. So after training it, we'll print summaries of the anomaly. So from the training set, it detected 46 anomalies, and testing sets, it detected 188 anomalies. And this is the recent anomalies from the data, the most recent. Here is just some feature importance and the mean errors based on prediction errors. Here is a function to predict the future values of anomalies that are predicted to happen. So it predicts that when VIX reaches $46.66, there is an anomaly, or 47, there is an anomaly, or 53 or 61. This is the only 5. Now for this, I wanted to predict only VIX Index's prices when anomalies occur. So I'm preparing the data again, scaling the data again, giving it parameters, preparing the sequence, training it, building an LSTM model, which also has 64 units and 34 units, and it will drop 20% of the data, so there is no overfitting. So after running this, it's training the model. It has done training it. So some of the more anomalies it detects is when VIX is on 23, 25, 23, 24, 24. So detect there is anomaly. This is the actual price, and this is the predicted price. This model still lacks accuracy. So this is some of the data analysis from the anomalies. It has saved all the results in a file called VIX Anomaly Prediction. When we open it, it's all the data sets we had, but now it has a new column where it decides if this price of VIX is an anomaly or not, compared compared to the training data sets. So it's all false. There should be some trues. Yes, like this. When it reaches 31, it detects it's an anomaly, or 32. Now we save it and read the prediction. And we only import the columns that have as anomalies set as true. So running it, there were 85 anomalies which were where is anomaly were true. So here is the anomaly details. There was an anomaly when VIX was 34, but our model predicted 27. So here is a chart of VIX price when there is anomalies. So all these red dots represent anomalies. Now distribution of anomalies that have happened. So in 2001 there was only 4 anomalies. 2002 there were 8 anomalies, and we can see 2008, as we know, when Lehman Brothers went bankrupt, so it detected 10 anomalies. COVID, we had 24 anomalies. Wow. But yeah, this is my project for market anomaly, and thank you for watching.